Let's look at another example. A field is shaped like the diagram below. It is a rectangle with semicircle at the two ends. There is a running track around the field. Remember, when we go around something, we have to find either the circumference or the perimeter of the shape. The question also says use 3.14 as an approximation for pi. Now, part A says find the length of the running track. Round your answer to the nearest 10 meters. I know that the track is going around this field, so I have to find the distance between from A to B, this arc AB, arc CD, and then I have to add that up with the distance from A to D and from B to C. So I'm writing this out as the length of the running track would be equal to the distance from arc AB, arc DC, and the distance from AD to BC. Now, in order to find the distance of this semicircle arc, I can use the formula to find circumference and then multiply it by 1/2 because this arc is half of a circle. I can just substitute the pi by 3.14 because that is the value of pi in this situation, and the diameter of this circle is 64 meters. So now I have 1/2 times 3.14 times 64. Remember, we multiply this by 1/2 because a semicircle is half of a circle. I know that 64 can be divided by 2 and gives me 32. So I am just going to multiply 3.14 times 32. On your computer or on your phone, you can also take out your calculator and do the same thing. 3.14 times 32 would give me 100.48 meters. Now remember that this semicircle AB and DC, they have the same length. Their diameters are the same length, so their arc will be the same length. So we just use the same formula. So for arc AB, we found out that it's 100.48 meters, and it is the same to arc DC. Now that I know the value of each arc, I can add them up and I can add it to AD, which is 100 meters, and BC, which is also the same distance as AB. So 100.48 plus 100.48 plus 100 plus 100 gives me 400.96 meters. But remember, the question says to round my answer to the nearest 10. So I'm going to underline this 10th place and then see whether 400.96 is closer to 400 or 410. Because the digit to the right is less than 4, so my number remains the same. This running track has the length of 400 meters. Part B of this question said that athlete ran around the track one time at an average speed of 8 meters per second. How many seconds did it take him to run around the track? Remember, when the question asks about distance, speed, and time, we can use this triangle, which when we circle what we are missing, we can figure out how to find it. So it's asking how many seconds it takes him to run around the track. We do not know the time. So what we can do is divide the distance by speed. So distance divided by speed would give us the amount of time taken. The distance of the track, we already know from the last question that is 400 meters, and the speed is 8 meters per second. So you can divide 400 by 8. Remember, 400 is the distance, and 8 is the amount of time, it's the speed that he took to run around the track. So 400 divided by 8 gives me 50 seconds. Let's pause and take a deep breath for a second. So far, we have learned how to find the distance around a shape that has semicircle as part of it. We also learned how to find the time it takes for someone to run around that shape using the triangle. So speed is one type of rate. Part C of this question says a gardener is hired to cut the grass in the field. She cuts the grass at an average rate of 40 square meters per minute. How many hours will she take to finish the entire field? Round your answer to the nearest hour. First of all, the grass in the field is no longer something that goes around it, but it is the grass that fill up the space. So in this case, we have to find the area of this field. The area of this field would be equivalent to the area of this the rectangle A, B, C, D, and the area of two semicircles. We can find the area of this rectangle A, B, C, D by using length times width. The length is 100 meters and the width is 64 meters. 100 times 64 would give me 6,400 square meters. Now that we have the area of the rectangle, we have to find the area of two semicircles. To find the area of a circle, you use pi r squared. But because this is a semicircle, so it is half of a circle, you use 1/2 times pi r squared. But because there are two of them, you can multiply it by 2. Now the diagram gave us the length of the diameter, but they didn't give us the length of the radius. So we have to divide the diameter by 2 in order to find the radius. Now the diameter is 64. 64 divided by 2 is 32 meters. So I'm going to write out my expression. 2 times 1/2 times pi, which is 3.14, times 32 squared. I can get rid of these 2's. So 3.14 times 32 times 32. You can use the calculator. 3.14 times 32 times 32 would get you 3,215.36 square meters. Remember that 3,215.36 square meters is the area of the two semicircles. So in order to find the area of this whole field, we have to add it to the area of this rectangle. So the rectangle ABCD is 6,400 square meters. The two semicircle is 3,215.36 square meters. Add them up and you get 9,615.36 square meters. Now that we know the area of the field, we have to figure out how long will it take for the gardener to cut the grass in the field. Now, remember that we can divide the area of the field by the rate in order to find the time taken by the gardener. So the area of the field is 9,615.36 square meters and the rate is 40 square meters per minute. So I'm dividing the area of the field by 40. Plug it in my calculator and I get 240 minutes and 3.384. The question want me to round into the nearest hour. So I first have to divide this amount into by 60 in order to convert it to hours. So 240.384 divided by 60 gives me 4.0064 hours. I'm going to round it to the nearest hour. So I would ask myself, is this closer to 4 hours or 5 hours? And I would say that it's much closer to 4 hours. So the gardener would take approximately 4 hours to finish cutting the grass the entire field. As we are moving on to the task, please make sure to rewatch the video one more time if you did not completely understand the lesson, and I'll see you in the next video.